Can everybody hear me okay? We're back.
Just make sure you do it directionally.
Right on your mouth.
Right on the mouth. Okay. That okay?
Eat the mic.
In the mic. I see the sinners that put the mic away. Anyway, my name is Mingchu. I work in the University of Alaska Fairbanks. I'm glad to see so many of you that I know of from the past because I have been here. Guess how many years I have been here? I came here as a black belt. Now you can see my belt. It's great. I've been here for 20 plus years. I have a lot of different working experience in Alaska. I must say that Alaska is very unique. And people need to learn the climatic conditions and the soil conditions. And the people, our people is different. I stay in Seattle for a week, for 2 weeks. I walk on the street, I see the people, I'm kind of scared of. Not because of they're not look like American, it's just because I don't know what's in their mind. But here in Alaska, in Fairbanks, I walk around, I know what people are thinking, I can respect, right? So this is, all people have our own culture, and we do need to appreciate that. Very, very pure in mind, pursue things very hardly, and works towards the perfection. That's a great thing. I mean, when Laura contacted me, asked me to give him a presentation, because I'm in the preparation for retire mode. I said, wow, this is a great opportunity because for this interior farm forum, we need this one for many, 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 many years, right? In the past, we only have one farm forum. That's in the Delta Junction. Here with the small grains. I'm not saying small grains are good, but we are so diversified state who have different interest groups. So we need this one, and I do hope this one will last beyond the project area or beyond many long time, so that everybody, flower people, vegetable people can get it together, exchange experience, and also professionals learn from each other, and also professionals can get feedback from the growers, and then they can develop their project according to the demanding from the society. Anyway, when I got that contact from Laura, asked me to give a presentation, I'm struggling. I said, which topic I'm going to talk about? Because I've been here for 20 plus years. I can talk sunflower, I can talk canola, I can talk small grains, I can talk peonies, I can talk cover crops, but I think I need to take a soil as the subject area. In this presentation, I may not have a lot of information in the research part, but I want just before your thinking to what are the fundamentals of the soil, right? I'm just talking without pushing the slides.
No.
Not looking.
Here, try now.
Yeah.
There we go.
So the thanks and appreciation, I said that already. As this slides. So my presentation would be, what are the basic functions of the soil? And then, what are the approach to improve that? So I would like to have an interactive approach. What is the basic function of the soil? Can anybody name a few of them?
Nutrition.
Nutrition. All right, that's good. What else? What?
Anchoring.
Anchoring. That's great. That's great. That actually is a primary function that we want in the soil. Nutrition, anchoring, what others? Moisture. And she just mentioned that watering issue. That's great, which is connected to the function-based soil function, watering, store water to supply the plant's need. What others? Microbes is a huge reservoir for microbes. When the scientific society name the frontier in science, I mean, you can name space, deep ocean, da, 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 but soil microbiology is also one of the last frontier because we know less than 5% of them. And it's a huge, huge resources for mankind. If we know, understand what are their functions, what they can do, bingo, you either be billionaire or you either be famous. Because we don't have a ton of means to culture remaining 95%. We know their gene sequence, we know they're there, and we don't know how do they function in the soil. Okay, so that's great. I'm anchoring. Have you ever tried think about tying a plant? I mean, maybe have done that. Tying a plant roots upwards, shoots downward. After a while, what do you think? The root will grow upward and shoot will grow downward? No way. The shoot will find its way upward, roots will find its way downward. You know, that's by studying. And the roots has to go to the soil, find the anchor, so that stay there to support plants. So remember that function, one of the functions as it is anchor. So soil provide a medium as an anchor to the plant roots. The other one is supplying water. How soil can hold water? I mean, you store the water, you have a basket or a container, 5-gallon pail, you hold a 5-gallon water there. How soil can hold water? I mean, in fact, if you see the distribution of freshwater reservoir, soil hold a majority of fresh water. And that's why when you have this sponsorship organization, people are from soil/water conservation district, why people link those two together. So how soil holds water? It has those small, tiny pores in soil. But that a pore space actually can function to hold water, right? So you see in that way, you have a pore space, and those pore space are not equally distributed in size. So they have large pores, medium pores, and small pores. And I will mention that later on, what those pores, these pores can function to in terms of plant growth. Nutrients, huge reservoir for the nutrients, right? Here I have a, is latent.
It's the
the red
red
line.
button.
Anyway, on the left-hand side of my side, you have those pails. Each pail represents a nutrient. Plants need 16 essential nutrients. What does essential mean? You have to have it. Without it, it will not grow, right? So it means if one is in short supply, the plant won't grow, no matter how little that one is required by the plant. So some nutrients required by large quantity, like nitrogen, phosphorus, potassium, sulfur, and others required by small quantity, like zinc, copper. The large quantity, we say 200 pounds per acre. For the small quantity, 2 pounds per acre. Right? So that's the contraction of large needed nutrients in contrast with the small amount needed nutrients. Nevertheless, they are equally important. If one is in short supply, the plant won't function. Right? So also, our soil contains nutrients. It releases out the nutrients for plant growth, except the nitrogen kind of limited in most of the soil. Otherwise, the mineral nutrients, they can supply from the wetlands of the soil minerals. The safe haven for microbes, right? huge amount of microbes. I mentioned that earlier, but I will mention that later. And basically, here I want to say, if you can see the right-hand side of your side, that's the mycorrhiza. Mycorrhiza is a fungi. It has to associate with plant roots, and it action to take out the nutrients because it releases acidic compounds to dissolve the nutrients and facilitate that uptake for plants, and the plant supply carbohydrates for the fungi. So that's kind of symbiotic relationship. In this hand side on the top, that is the allogel, rhizobium in connection with the legume plants, like soybeans, alfalfa, and the rhizobium fixes nitrogen, and the plants supply carbohydrates. These are two typical examples. Humans use the microorganisms, and so many other remains we don't know yet. So those are the basic functions: anchoring, supply water, nutrients, microorganisms. So then the next question you need to think, so what are the optimal conditions for soil to function fully for those functions, right? So what do you think about the anchoring? We have organic soil. I remember one time I have this purely presentation. I made a presentation, did an experiment in has a field which has a peat moss treatments, fertilizer treatments, and the peat moss treatments perform poorly. And the guy after presentation said, "Thank you for your presentation. I just bought a peat and I'm planning to grow peony. I'm going to just cancel this purchase for peony, peony roots." So what are those soils or those medium can function as the best anchor for your plants you're going to grow? You have here we have organic soil, which is like peat moss, your potting materials, or high clay content soil. High clay?
Yeah.
Okay. What others? Loamy? How about sandy soil?
No.
No?
It drains well.
If it drains too far, that's connection to the water issue, but it you provide large force, plant penetrates easily, right? But then when it penetrates easily, with the wind blowing, what happens? Flip over, right? Same as organic soil, that way you have too. Clay soil is good as long as the roots has a good penetration through the clay soil. Otherwise, it has respiration issue, water issue, because tiny pores, the water stored in the tiny pores is hardly be used by plants. So the loamy soil is a good one. Fortunately, our Alaska soil is in the loamy category. Most of our Alaska soil, you close your eyes, you take a soil, it's in that kind of category. But I will mention what's the pitfalls for our soil. Loamy soil, easy root of penetration. So what about water? Which soil can hold more water? Loamy soil can hold more water. You see this curve here, and this have a sand, sandy loam, silt loam, clay. This is the amount of water the soil can hold, right? This is the water hold in soil as we increase in clay content. However, that soil, even though held by soil, that water is even though held by soil, but it cannot be used by plants. Because plants only have a certain amount of power to take out the water from the pores. So this is the amount of water available What is the other limits there? That is the term called field capacity, which is a maximum amount of water a soil can hold against the gravity. So the difference of that amount of water, for the amount cannot be used, the amount that can best hold by soil, that's called available water. So loamy soil, as you can see from this curve here, the difference here is wider, right? So that holds more water for your plants to use. For irrigation purpose, if you irrigate a sandy soil, the amount of water you irrigate each time should be less, but frequency should be more. For clay soil, same thing. The droplets frequency intensity should be low, otherwise it's got a runoff issue, right? So this is all related to the water. Loam soil can hold more water. Okay, nutrients. Again, soil has a lot of nutrients, right? Some nutrients is released from the soil mineral weathering process. Like those particles, soil particles break down over the years, right? Our soil particles originally is a rock. Over many, many years become those small particles, right? And that process still going on. In that process, it will release nutrients. And that nutrient will be used by plants. And those are such as the calcium and the magnesium. The others, mostly released by organic materials. Without the human interference, where is the organic materials in soil coming from? Any ideas? Without, I mean, of course, you apply manure, apply residues, but without human interference, soil still have organic matter. But where it is coming from? Microorganisms, worms, decomposition of leaf litters, right? And this leaf litter decomposition release nutrients, trees take up again, or again, that's the cycle. But with our interference, we push more because we want more, right? So that's the human interference cycle. Natural cycle is the natural decomposition process, but we put more for nitrogen and we want more decomposition in order to release more nitrogen and sulfur. So microorganisms, I mentioned that too. So one is the legumes, one is for the mycorrhiza. For mycorrhiza, this one thing, I mean, I don't know if somebody here do the reclamation purpose. I mean, one of the things in the reclamation land, freshness, topsoil is totally removed. If you put some leaf vegetation there, you better mix some old soil there, because it contains the mycorrhiza that plant needs. The example of this one is people plant the willow in newly fresh soil, it only grows. Unless the willow shrub is soaked in old soil for 1 hour and then plant, the willow grow much healthy because mycorrhiza, right? So something is just, you cannot see, but you cannot ignore. So mycorrhiza, which is very important for the some majority of the plants. Yeah, okay, mentioned this already. So the other thing is reality check. What's our soil? Our soil, I mean, you can have Nebraska soil, Washington State soil. What's the unique of our soil?
It's glacial.
It's glacial, it's low, mostly it's low. Still, what is the general impression of our soil here?
Low organic content.
Low organic content, number one. What is the other? I said it. What's the other? Cold. That's very important, cold. I mean, that dictates where do you put your nutrients? You put your nutrients deeper on the wood, because the roots cannot go down there, right? So that's low in organic matter content. We have a grassland, we have residues. Well, our residues just decompose on the surface because we don't have earthworm. I mean, nowadays you see the invasion of earthworm, but that's only in the garden, not in the farmland. Well, in Nebraska or those Montana, they have earthworm, people cleaning the soil, we mix with the organic residue with soil, then they have a black soil. Our organic residues is stratified. You can see the layers. You cut a fresh native land, you can see the organic matter mostly on the surface, right? Lacking organic matter, as I mentioned earlier, lacking organic matter means less in nitrogen, sulfur supply, right? Because those are two related to the supply. Cold soil means what? Number one, plant the roots won't go down. Slow germination, and also restrict to phosphorus availability. Because phosphorus is very, very sensitive to mobility, solubility. It's very sensitive to temperature. Low temperature, even though you have phosphorus there, they won't mobilize for plants to use, right? So these are the reality check. Our soil is also mild, less weather, which also give an advantage for our soil compared to the soil in the low 48. Our soil very, very rich in potash. You go back to check your soil test record. Most of our soil, okay, potassium content, 80 parts per million to 100 parts per million. You level short of those nutrients. Or you add a little bit more, that will help. But it won't go anywhere, it will stay in the soil. Cold soil also have another result, is slowly decompose of organic residue that will slow the release of the nutrients there. And also, what we said, we have a human interference system. Quality of organic materials very important. Here in this field, this is our farm field, and we have a small grade test in this field. And we usually very evenly apply nitrogen fertilizer across the field. When you have a uniform apply nitrogen across in the field, you should have a uniform, you should expect uniform plant growth, right? But what you see here, close to me, is very green. Somewhere, but far end is kind of a yellowish. Yellowish means what? No nitrogen content. Why there's a spot that lack of nitrogen? Because when we call the straw residue from previous year, that is a place have a deposition of the residues, right? So residue, you apply nitrogen, and you apply nitrogen, and the residue start decomposition. Who is the one to do the decomposition process? Microorganism. When microorganisms want to decompose the residue, that's their food. They also need to take a nitrogen. They have much high competitiveness as compared to plant roots. So they said, you go away. This is mine. If the microorganisms take it, so that's why plants show the yellowish deficiency in nitrogen. So the quality of organic residue is also a consideration when you use for maintain the good nutrients there. So approach to achieve the optimal conditions. What's my 5 minutes? I have to speed up a little bit. So apply good amount of high quality of organic residues. So also when you apply nutrients, amount, timing, and the method of application that you need to pay attention. And also quality of irrigation water. I just short mention that because that's easy. Quality of irrigation water is because your pH of water make a difference. Temperature too. That's very good. I just always use a mimic. If you walk in the summer outside, somebody put a cold shower of water on your head. What do you think? No, right? Warm water would be okay, right? Room temperature water would be okay, cool yourself down. But that cold water, you don't like it, one doesn't like it too. So recommendation is you have a tank, warm that water a little bit, and then start a shower on the top of the plants. And also the pH, right? I will have a picture, which means the soil will not deficient in plant nutrients. Usually plant nutrients, micronutrient deficiency at a higher temperature. But when you have micronutrient deficiency at a low deficiency occurs at higher pH. But usually our soil is acidic, right? When you have irrigation water is high in pH, and after years your soil changes in pH, and then your soil show micronutrient deficiency. I will mention that later. So apply good quality of the organic residues. When you apply nutrients, you remember amount. How do you determine the amount? You needed to do a soil test there, right? Soil test is not very expensive. I'm not promoting that aside the lab, commercial lab there, just because we all do send our samples there. Our professionals develop our understanding for our soil based on that lab. So we send the soil sample there about $20 per sample. And the timing, you not apply soils, plant nutrients at the fall. You apply at the fall because fertilizer is cheap, and then you just apply at the fall. And then for nitrogen, you will go runoff, electrification is all gone. Even though you think I did my job, I apply fertilizers, but actually they are gone through the process, right? A method of application, do not expose any nutrients on the surface. Apply nutrients closer to the where the plant roots are. The quality of the organic residues. When you want nutrients used by current plants, you need to use low serum ratio materials. What are the low serum ratio materials? Young plant clippings, legume plants residues, manure, but manure has need to put a hesitation there or put there. What type of manure? You have a cow manure, horse manure, that is totally different. Okay? Horse manure, because what's the bedding material horse use? Straw. You usually have a straw along with, with, but chick manure, that's a very good quality one, right? So you need to, this table, this material, 1 minute, this table is available, you can check that. Low serum ratio one is the one that you can come out instantly benefit your plants this year when you apply. High serum ratio materials usually years later you get benefit. Okay. Horse manure, cattle manure, I mentioned that. Compost one. Compost manure better than non-compost one because it have concentration of the nutrients. And when you apply that, you will instantly benefit from down.
You're okay.
Like 30 seconds.
Green clippings, early green clippings, not the later ones. Later one will act like a straw. Early one will act like a nutrient source. Age and height. Legume versus grass clippings, the early ones should be better. Legume versus non-legume, of course, legume is better because it fixes nitrogen. Sawdust, wood chips, straws. Those ones will take forever to decompose in your soil. If you want instant benefit for your plants, it won't do that, right? But it will do for a long time. And also depends on the sawdust, because elder sawdust is better than your the pines, okay? Elder is a legume, kind of a nitrogen fixation plant, where others is not.
Do we really need to look at the next person?
Okay,
Sorry.
yes, yeah, I mean, the presentation is there, I just, you know me. And, this is the example of the, irrigation, what is high pH, the contribution deficiency in the plants. This is an example in here, in Alaska. So this is my contact information. You can contact me, shoot me an email, and I will help you. You are my priority, just like what I always told my students, you are my priority. Because I'm here to serve our client.
Make sure, is it okay if we put this presentation up on the website?
Yeah,